Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over unit analysis and conversions. I'm going to do this by doing some practice problems. So in unit analysis, this is where you are basically using conversion factors to convert from one unit to another unit. So let's get into this. So the first problem is asking you to convert 4,567.36 micrograms to kilograms. So as I've said before, when you're going from one unit with a prefix to a different unit with a prefix, unless you know exactly what that relationship is, it's better just to go through the base unit as a middleman. So you should know what the prefix means, and you should know what the prefix multipliers are for each prefix. So let's start this problem. So here I'm going to start with the micrograms. So they give us 4,567.36 micrograms. That weird M means micro. That's the prefix. We're going to put that over 1. And we're going to start our conversions. So the first step is going to be converting to the base unit. So I need to know what the relationship is between grams, the base unit, and micrograms, which means I need to know what micro means. Micro is the prefix, and I know that micro stands for 10 to the negative 6. That's the multiplier for micro. So if I write that over here, if I put my microgram is equal to a certain number of grams, right? So I set up my equality. And so I always put the 1 with the micro. So I put 1 there. And since I know what what micro means, I'm going to put that in the other side with the base unit. Micro is 10 to the negative 6, or 1 billionth or I'm sorry, 1 millionth of a gram. So it's going to be 10 to the negative 6. So that's my first conversion. So we'll use that. So I have micrograms here. So micrograms is going to go on the bottom. So 1 microgram on the bottom. And on top is 10 to the negative 6 grams. So micrograms cancels out. Now I have grams. Now I can convert grams to kilograms. So kilo, again, is the prefix. So I'm going to set up my equality. So here again, I'm going to have kilogram is equal to some number of kilograms is equal to some number of grams. So I always put the 1 with the prefix. And the other side gets the multiplier. Kilo means 10 to the third or 1,000. So I'm going to put that on this side here. So now that's my second conversion. So I'm going to set up my conversion factor. This time I have grams on the top, so I want grams on the bottom. So it's going to be 10 to the third grams on the bottom. And I'm going to put 1 kilogram on top. So grams cancels out. I've got kilograms on top. I am done. That's the unit we want. So we go ahead and use our calculator to multiply and divide. Everything on top gets multiplied. Everything on the bottom is divided. So when we do that, we get, let me double check. So we're going to get 4.56736, right? And multiply that by times 10 to the negative, oops, give me a second here. That's going to be negative, give me a second. All right, sorry about that. 10 to the negative 6 kilograms. And that, ladies and gentlemen, is going to be the answer in kilograms. So there we go. Okay, so now the next problem is we want to convert 475 miles to kilometers or kilometers. So again, we're going to start with what we're given. So 475 miles, MI for miles, over 1. And now we want to convert miles to something. So if we know the number of feet, we can convert it to feet, and then we can convert it to inches and so on. So here, again, it depends on what conversion factors you use in order to convert from one thing to the other. Here, we use the metric system. Here, we're using the English system. We will want to convert to the metric system. So how you do that is really up to like what conversions you're given in the problem or what conversions you find. So I'm just going to convert this to feet because I know that 1 mile is equal to 5,280 feet. Okay, so 1 mile goes on the bottom and 5,280 feet goes on top. So miles cancel out. Now I have feet. So now I can convert feet to inches. I know that 1 foot is equal to 12 inches. So I'm going to put 1 foot on the bottom and 12 inches on top. So now feet cancel out, and now I have inches. And finally, I can use my inches to centimeters to convert from the English system to the metric system. So here we have, so I have inches on top. I'm going to have 1 inch on the bottom, and 1 inch is equal to 2.54 centimeters. So 2.54 centimeters. Inches cancels out. Now I've got metric. So now I can convert centimeters to kilometers. But again, I'm going to have to go through the base unit to do this. So first, again, I'm going to set up my equality. So here I have centimeters. I want to get to meters. So I have a certain number of centimeters that's going to be equal to a certain number of meters. So I always put the 1 with the prefix. So centi is the prefix. Centi means 1/100th or 10 to the negative 2. So 10 to the negative 2 meters. And so I can set that up here. So I have centimeters on top. So I'm going to put centimeters on the bottom. 1 centimeter on the bottom and 10 to the negative 2 meters on top. And now finally I can convert meters to kilometers by doing the same thing that I did here. So 1 kilogram is equal to 1,000 grams. 1 kilometer is equal to 1,000 meters. So I'm going to have 1 meter on the bottom and 10 to the third. Oops. Sorry about that. I just caught myself. So remember, I put 1 with the prefix unit. So it's going to be 10 to the third meters and 1 kilometer on top. So meters cancels out. Now I have everything that I want. I have kilometers on top. Now I'm just going to multiply by everything on the bottom, and I'm just going to multiply by everything on top and divide by everything on the bottom. And when I do that, I get 764 kilometers. Now, I want to go back and talk about significant figures. So if we go back to this problem here, remember, according to the rule, when we're doing significant figures or sig figs, the answer that we get must have the same number of significant figures as the inexact measure that with the fewest significant figures. So here we have 1, 2, 3, 4, 5, 6, right? We have 6 there. Now, the key is that we want to use inexact measures, not exact measures. And any relationship between metric units is exact. It's true by definition. So this is exact, and this is exact. So they have an infinite number of significant figures, so we can ignore those. So therefore, since this has 6 significant figures, our answer should have 6 significant figures. So here, our measure is 475. We have 3 sig figs here, 4, 7, and 5. And here we have a English to English conversion. So whenever you are converting between English and English, or metric and metric, that's going to be exact. That's going to be true by definition. When you're converting between English and metric, between those units, then it's going to be a measure. There is one exception that I will talk about in a moment. So here we have English length to English length. That's going to be exact. Here we have English length feet to inches. That's going to be exact. Now here we have English inches to metric centimeters. You would think that this is going to be a measure, but this is one of the exceptions. So this is an exception. So this is going to be exact. So 1 inch is exactly equal to 2.54 centimeters. Okay, so that's exact. And then here we have our 2 metrics, so centimeters to meters and meters to kilometers. So these are exact. These are true by definition. So all of these are exact relationships. They're not inexact. So we ignore them because they are going to have an infinite number of significant figures. So since this is the only measure, this is the only inexact measure that we're using. So this is going to be 3 sig figs. So therefore, our answer here should have 3 sig figs. Okay, let's talk about number 3. What is the volume in liters of 64.567 pounds of ethanol at 28 degrees Celsius? So we're going to start with 64.567 pounds. And again, since we have English units, we can convert this in a lot of different ways. We want to get to liters, which is a metric unit of volume. So we're going to have to convert our weight or mass to volume. So we want to first convert this to grams. So let's use our grams here. So 1 pound, I don't have room to write it. 1 pound is equal to, let me double check, 453.6. So 1 pound on the bottom, and let me double check. That's going to be 453.6. So 453.6 grams. Okay, so here pounds is going to cancel out. Now we have grams. And so let's see here. So in order to convert from our mass to volume, we're going to need a volume to mass ratio, and that's where the density comes in. So remember, you can use density as a conversion factor if you're given it. We're not given it in this problem, but you can look it up in the table. So if you look that up, I'll provide it for you. So if we look it up, that would be 0.7893. So 0.7893, 0.7893 grams of the ethanol is going to be equal to 1 milliliter of the ethanol. So I'm using the density. Density is mass over volume, but I can use this as a conversion factor, and with all conversion factors, you can flip the units, or you could flip the conversion factor to get the proper unit on the bottom. So since I have grams here, I want grams on the bottom. So now grams will cancel out. Now I have milliliters, and so now I can convert to liters. So remember, so I have liters, some number of liters is equal to some number of milliliters. So I put the 1 with the prefix. So 1 milliliter is equal to a certain number of liters. This is where you need to know the prefix multiplier. So milli is 1/1000th of something. So this is 10 to the negative 3. So 10 to the negative 3 is the blank. So here, 1 milliliter is 10 to the negative 3 liters. So I can set that up. So milliliters goes on the bottom since I have milliliters on top. So this is 1 milliliter on the bottom and 10 to the negative third liters on top. Milliliters cancels out. Now I'm done. I have my liters. So now all I have to do is multiply across the top and divide by whatever's on the bottom. And when I do that, I get, give me a second, 37.11 liters. And again, significant figures here. So when you're using significant figures, oh, give me a second. So here we have 1, 2, 3, 4, 5. We have 5 sig figs here. And again, when you're multiplying and dividing, the rule is that your answer should have the same number of significant figures as the number of significant figures in the least, how should I say, in your inexact measurements. So whichever inexact measurement you use that has the least number of significant figures, your answer should have that same number. So let's look at this. We have 1, 2, 3, 4, 5. We have 5 sig figs here. Here we have 1, 2, 3, 4. Here we have 1, 2, 3, 4. This 0 is not significant. It's just a placeholder. So we have 4 here, and 5 there. This is exact, right? So the least number is 4. So that means your final answer should have 4 sig figs. So we have 1, 2, 3, 4. That's why it's 37.11 liters. Okay. Finally, let's talk about this one, number 4. So we are given 2.3942 kilograms. So when 2.3942 kilograms of glucose are burned or combusted, 37,230 kilojoules of heat are evolved. It's released from the reaction. That means that the system, the reaction lost energy. That's going to be a negative number. So they're asking what is the heat of combustion of glucose in joules per gram. We're given kilojoules and we're given kilograms. So we can write that as a fraction. So here we can start with 2.39. Oops. Notice that they want the energy unit on top and the mass unit on the bottom, joules over grams. We have kilojoules, so we're going to put kilojoules on the top. So we have 37,230 kilojoules. And we're going to put that over the mass. They want grams, but we have kilograms. So we're going to put kilograms on the bottom, 2.3942 kilograms. Okay, so now we have our ratio that they want, but the units are different. So we're going to convert the units. So give me a moment just to double check to make sure I got this right. Yep. Okay. So now all I'm going to do is start converting. Now in this problem, we have both the top and the bottom unit to convert. So we're going to have to do one at a time. It doesn't matter which one you start with. I like to start with the top, so I'm going to start with the top. So here I have kilojoules and I want joules. So what's the relation between joules and kilojoules? So I have joules is equal to some number of kilojoules. I always put the 1 with the prefix, so 1 kilojoule, and then the prefix multiplier goes with the base unit. Kilo is again 1,000 or 10 to the 3. So 10 to the 3 joules is equal to 1 kilojoule. So I'm going to use that to convert. So kilojoules are on top, so I'm going to put kilojoules on the bottom. So 1 kilojoule goes on the bottom, and then 10 to the third joules goes on top. So kilojoules cancels out. So now I have joules on top, which is what I want. They want joules, so I'm done with the top. So now I do the bottom. They want grams on the bottom, so I'm going to convert kilograms to grams. So here, kilograms is on the bottom, so I want to put kilograms on top. So again, our relationship is grams, some number of grams is equal to some number of kilograms. So it's the exact same relationship. One, I'm going to always put one with the unit, the prefix, and then the prefix multiplier with the base unit. So now I have kilograms on the bottom, so I want to put kilograms on top. So here 1 kilogram is on top and 10 to the third grams on the bottom. So the kilograms unit cancels out. So now I have my grams on the bottom, which is what they want. I have joules on top, which is what they want. So I am done. So I'm just going to calculate. Now you can see here that 10 to the third here and 10 to the third here are going to cancel each other out. So basically you're dividing this number by this number. And when you do that, you get 15,550 joules per gram. Double check that. And again, a word about sig figs. So here, these are exact, right? Metric unit to metric unit, metric unit to metric unit, mass to mass, energy to energy. So these are exact. So we're going to ignore those. So here we have our two measures that they gave us. This has 1, 2, 3, 4 sig figs, right? This 0 is not significant because there's no decimal point there, so be careful of that. So this 0 is not significant, so we have 4 sig figs here, and we have 1, 2, 3, 4, 5 here. So our answer can only have 4 sig figs. So you'll notice there's a 1, 5, 5, 5. That's 4. This 0 is not significant. That is just a placeholder. So this is our answer in the proper number of sig figs. And that, ladies and gentlemen, is how you do unit analysis and conversions with conversion factors. I hope this was helpful. If this helped you in any way, if you enjoyed this video, then please like my video. Hit that like button over there. Please subscribe to my channel. Hit that notification bell so you can be notified by all the videos I put out. When you hit that notification bell, make sure you click all so you see all my videos. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.